Okay, so let's look at an inequality, a simple inequality that we know is true. 4 is less than 8. We know that's true. Now my question is it okay to add, subtract, multiply, and divide both sides of an inequality? So let's look at this inequality, 4 is less than 8. Is it okay to add to both sides of the inequality? Say I add 1 to both sides. If I add 1 to both sides, I now have 5 is less than 8. And that's still true. So it looks like I can add to both sides of the inequality. Let's go ahead and subtract from both sides of the inequality. So subtract 1 from both sides. I would get 3 is less than 7. That's still true. Okay, let's go ahead and multiply both sides of the inequality. Let's multiply both sides by 2. 4 times 2 and 8 times 2. That gives me 16 is less than, 8 is less than 16. That's still true. Let's go ahead and divide both sides by 2. So I get 2 is less than 4, and that's still true. So it looks like we can go ahead and add, subtract. Oops, when I added wrong. It should have been 9 right here. I caught that. So like when I add to both sides of the inequality, it's still true. When I add or subtract the inequality from both sides, it's still true. When I multiply both sides, it's still true. And I divide both sides, it's still true. But what happens if I were to multiply both sides by a negative number? Let's say I multiply it by negative 2. It give me negative 8 is less than negative 16. That's not true anymore. That's actually false. Okay. If you look at the number line here, if there's 0, negative 8 would be on the side, and negative 16 would be on the left-hand side of that. The negative 16 would actually be smaller, and negative 8 would be larger. According to this, saying negative 8 is smaller, so this is false. The only way to make it true is to make the inequality true, to go ahead and reverse the inequality sign, and now it's true. Okay. And let's say I were to divide both sides of the inequality by a negative number. Let's say divide by negative 2. That gives me negative 2 is less than negative 4. That's false. Because if you look at the number line, negative 2 would be right here, and negative 4 would be right there, and negative 4 would be smaller. If you look over here, you're saying negative 4 is larger, so that's not true at all. To make it true, we'd have to reverse the inequality sign. Now it's true. So we just discovered here that solving inequalities is the same as solving equations. We can add, subtract, multiply, and divide both sides by the same value. However, if we multiply or divide both sides by a negative value, we must reverse the inequality symbol. Because if you know how to solve equations, pretty much you know how to solve inequalities. Just remember that if you multiply or divide both sides by a negative value, you must reverse the inequality symbol. Okay. Here's a hint to our time students. Whenever we're solving inequalities, it's always helpful to solve by keeping, or solve, or actually it's helpful to have x on the left side. So when we were solving equations before, it didn't matter which side we had x on. X was on the right hand side or left hand side. But with inequalities, it's helpful to have x on the left hand side because it's standard to write an inequality with x on the left hand side. Okay, so I'll do that in this section. The common mistake I want to talk about is a negative answer has no bearing on whether you reverse an inequality symbol. So here's an inequality here. If I were to solve for x, I would divide both sides by 3. Notice how I divide it by a positive value. So that means I don't reverse the inequality symbol. 9 divided by a negative 9 divided by 3 is negative 3. Even though I have a negative value here, my inequality symbol does not reverse because I divided both sides by a positive value. Now this one right here, if I divide both sides by negative 3 to get x alone, I would reverse the inequality symbol because I divided both sides by a negative value. Okay, so here we actually reversed, and then here we didn't reverse. Okay, I don't care if this value here is positive or negative. All I care about is what you divide both sides by. Okay, let's go ahead and solve this linear inequality. 3 minus 2x is less than or equal to 11. So I'm going to solve like I would an equation. I'm going to go ahead and subtract 3 from both sides. So I get negative 2x is less than or equal to 8. And I have to divide both sides by negative 2 to get x alone. That gives me x. Now just reverse the inequality symbol. So it's greater than or equal to negative 4. Okay, because I divided by negative 2. And I'm going to go ahead and graph it on a number line. It's negative 4. Then I'm going to shade everything greater than negative 4 to be on this side. And I'm going to include negative 4, so I'm going to go ahead and use a bracket there. Interval notation will be from negative 4 to infinity. And set bill notation will be a set of all x such that x is greater than or equal to negative 4. Okay. Now if I want to check to see if this was right, if I've shaded the right side of the number line, I pick a number on this side, a number like negative 3, negative 2, negative 1, 0, and so on. So you can use any value here to check. So I'm going to check using the number 0, because that would be on this side. 3 minus 2 times 0, is that less than or equal to 11? 3 minus 0, less than or equal to 11. Well, 3 is less than or equal to 11. That's true. And it would be true if I were to pick negative 3. Okay? I'll do one more. So if I do 3 minus 2 times negative 3, that less than or equal to 11. That'd be 3 plus 6, and that'd be 9, and that's true. Okay? You don't have to check it, but I always tell students that it's good to check if you're unsure if your answer is correct or your inequality is incorrect at the end. Okay, so I'm going to go ahead and pause the video and have you try this one on your own. And then replay the video, and then you'll see if your answer is correct. Okay, so when you solve this, you should get x is greater than or equal to negative 1. Here's my graph, my interval notation, and then my step bill notation. Okay. Let's go to example 4. We're going to solve and graph the solution at a number line, and also state and set bill notation and interval notation. So again, we're going to go ahead and we're going to solve it. And notice how x is on both sides. So I said the little hint is to go ahead and try to get x on the left-hand side here. So we can get rid of this x here by subtracting x on both sides. I get negative 3x minus 4 is greater than 5. And then I add 4 to both sides. So I get negative 3x is greater than 9. And then I divide by negative 3 to get x alone. So x is less than negative 3. I had to reverse the inequality symbol because I divided by a negative value there. Okay. So my graph is on a number line. And negative 3 is right there. And I want all the numbers less than negative 3. So I'm going to shade in this side of the number line. Now I'm not going to include the negative 3. You parentheses. We go from negative 3 to negative infinity to negative 3. And then my step notation means that of all x such that x is less than -3. So again, I'm going to have you pause the video and do the on your own problem here. And then when you replay it, you can go ahead and check your answer. Okay, so I went ahead and did the on your own problem and check your answers with mine. You should have x is less than 4. The graph is right there. Arrow notation is right there. And there's your step notation. Okay. Again, if I want to check this, I would choose a number less than 4, like 3. Put 3 in here, that would be 9 plus 1, which would be 10. And then put 3 in here, that would be 21 minus 15, which would be 6. Is 10 greater than 6? Yes. Like that checks. Let's go to example 5, and we have an inequality here, and if this were an equation, you would clear fractions. Let's go ahead and clear fractions. Okay, so I'm going to go ahead and multiply both sides by the LCD, and that would be 12. And then we'll take 12 times this and 12 times that. I get 12 times x plus 3 over 4 greater than or equal to 12 times x minus 2 over 3 plus 12 times 1 over 4. I go ahead and reduce. I end up with 3 times x plus 3 greater than or equal to 4 times x minus 2 plus 3 times 1. I get 3x plus 9 greater than or equal to 4x minus 8 plus 3. Now if I go ahead and combine like terms on the right hand side, I get 4x minus 5. We'll go ahead and subtract 4x from both sides. So I get negative x plus 9 is greater than or equal to negative 5. I'm going to go ahead and subtract 9 from both sides. So I get negative x is greater than or equal to greater than or equal to negative 14. We divide both sides by negative 1 because there's a negative 1 in front of there. So x is going to be less than or equal to 14. I reverse the inequality symbol because I divided by a negative value there. Okay, so the graph is going to look like this. I want values less than or equal to 14, so less than 14 over here. And then use a bracket including the 14. So go from negative infinity to 14. And it didn't say to do interval notation, so I went ahead and did it anyway. There's the notation, there's the graph, and it didn't have step notation, but the step notation would be right there. Okay. Again, all I asked for was the graph and then the inequality, solving it. Okay, so here I went ahead and cleared fractions on both sides by multiplying the LCD. That's something we did in the last section.